Welcome back to the deep dive. Today we're jumping into some really interesting stuff. We've got lecture notes here titled CAFA Platform, the Genesis of AI Agents.
Right, and these are from Jaewa Choi, who's not only an associate professor at George Washington University, but also the actual inventor of the platform.
Exactly. So our mission today is pretty clear. We want to pull out the most important nuggets from these notes. We need to get a handle on what this CAFA platform, and it's pronounced like Kappa, Shepa, what it actually is, how it works fundamentally, and, why it matters, especially if you're thinking about building serious generative AI agents, maybe without being a super expert coder.
And it's important context, I think, that the notes frame this platform as just one part, albeit a key part, of a bigger CAFA ecosystem. The focus really seems to be on providing a practical, accessible environment, very low-code focused.
Right. So think of this as our guided tour. We're going to explore the core ideas, see how you'd actually use it, and figure out the main building blocks. Okay, so let's unpack this. How about we start with where it came from, the background?
Sounds good. So fundamentally, the CAFA platform, you can find it online. It's presented as this digital environment specifically for designing, deploying, and then managing these things called CAFA agents. Built pretty squarely for generative AI.
And what really leaps out, like you said, is that goal. User-friendly, low-code. The notes are quite explicit. It's about empowering users who aren't necessarily programmers, educators, experts, researchers, letting them build complex agents. That feels pretty significant for you, our listener, if you've got that deep domain knowledge, but maybe not the coding background.
Oh, absolutely. That accessibility seems central. The notes trace its history a bit, too. They mention earlier versions, maybe like a CAFA 1.0 concept that were more manual, maybe focused on specific things like generating assessment items. But the current version, CAFA 2.0, that's what we're digging into. And this version fully leans into generative AI, especially LLMs.
Yeah, and here's where it gets really interesting, I think.
Yeah.
The notes flag a specific moment, late 2022, when powerful LLMs like GPT burst onto the scene. And that wasn't just a small tweak. It looks like it fundamentally redirected the project, moving away from purely manual modeling towards figuring out how to slot these powerful new AI models into their existing structure and ideas.
Exactly. And that strategic integration leads right into the platform's core philosophy. It's called Ontology Model-centered Generation, OMG.
OMG.
Yeah, and the notes really emphasize this. It's not just a feature. It's positioned as the defining theoretical framework for the platform and central to CAFA's work overall. To really get it, they contrast OMG with other ways people use LLMs. There's what they term logog language model only generation. That's basically just, feeding it raw text or a simple prompt.
Kind of hoping for the best.
Pretty much. Then there's RAG, retrieval augmented generation. That's better, pulls in information for context, but maybe without deeply structuring that information first. OMG, though, is presented as fundamentally different. The idea is to feed the LLM highly structured, task-specific, context-aware knowledge. And this knowledge comes from what they call a predefined ontology model. Think of it like a tailored knowledge map for the specific job the AI needs to do.
Okay, so practically speaking, what does that mean for building AI? The notes argue pretty strongly that grounding the AI in this kind of explicit, validated, structured knowledge makes a huge difference to the output. We're talking better quality, more consistency, better factual accuracy, and this seems key interpretability. You can understand why it produced what it did.
Exactly.
And why does that matter? Well, especially for specialized areas, education, research, enterprise stuff, you can't just have an AI riffing creatively based on statistics. You need reliability. OMG is pitched as the way to provide that reliable knowledge base.
Precisely. The platform's whole emphasis seems to be quality AI output in specialized domains depends heavily on the quality and structure of the knowledge you give it. Just dumping unstructured text isn't as effective as guiding the LLM with well-organized ontological info like, say, a curriculum structure, learning objectives, a specific rubric. That structure acts as a crucial scaffold.
So, bottom line, the LLMs aren't just, running wild here. They're powerful, yes, but the OMG framework uses structured human knowledge to guide and constrain them, turns them into specialized tools. Okay, let's shift gears a bit. How do you actually use this thing? The notes seem to start with something really fundamental, access and security.
Yeah, they really stress that. Users need to be responsible for managing their credentials securely. You set up and manage your keys through the user portal ai.kifalab.com.
Okay.
And there are two main key types you need to handle. There are CAFA keys, for the platform itself, building and running agents.
Okay.
And then you got keys for any external LLMs you use, like maybe your OpenAI GPT API key.
And the notes include a pretty serious warning here, right, about sharing keys.
Oh, definitely. Big risks, security issues, potential misuse, and importantly, you could get hit with unexpected costs.
Yeah.
If someone else uses your API keys, those calls get billed to you. So managing API limits, storing keys securely, the notes frame these as essential first steps, not just nice-to-haves.
Right, critical housekeeping before you even start building. So once that's sorted, you get into the agent modeling interface. And the core idea comes up again, making AI development accessible through this low-code approach.
Exactly. The environment is built around what they call advanced prompt engineering. But it's not just about writing clever prompts. It's presented as more systematic. Methodical design, combining prompts with parameterized inputs and structured data drawn from those ontologies we talked about.
Strategic prompt engineering, why that way?
Well, the goal is precision, consistency, getting reproducible results, not just, random creativity. And a key part of this systematic approach is breaking complex tasks down into logical steps or turns. We'll probably talk more about turns later.
Okay, walking through the interface described in the notes, you can see that structure. There's a top panel for agent setup authentication, connecting your keys securely, naming the agent, setting access controls, warnings about keeping keys secure right there too. Then a big middle section is where you actually define the agent, its title, description, and crucially, where you set up its knowledge building blocks. This is where you define parameters.
Right, the parameters live there. And then below that is where you map out the agent's behavior over time. The prompts and turn configuration area. This is where you design the sequence of interactions, the turns, what happens in each step, what prompt goes to the LLM, what data gets processed, when does it wait for the user.
And for each turn, you can tweak the LLM settings.
Yeah, things like temperature for creativity, max tokens for length. You can even ask for structured output like JSON, select the specific LLM model, lots of control per step.
Okay, and then standard buttons save, load, import, export your agent designs.
And a panel for testing and debugging too. See the inputs, outputs, follow the turn logic step by step.
Right, so this interface with its clear sections for setup, parameters, and the turn logic, that's the heart of the low-code knowledge-guided development process.
And powering a lot of that structured logic and data flow is what the notes call the CAFA protocol's parameter system. Parameters are described as, fundamental building blocks. They define variables, hold structured knowledge. They're essential for managing how information flows, especially in agents that do things in multiple steps.
Okay, and there are different types.
Two main types mentioned. User-defined parameters, which you as the designer create. They hold your specific content or logic. And then system parameters. These are reserved, managed by the platform automatically. They control the application flow, pass data between turns. You don't create them. The system uses them.
Let's focus on the user-defined ones first, since those are what you configure. The notes say you give them a name.
A unique identifier, yeah, like greeting options.
A value which could be text, or maybe a list separated by that pipe symbol.
Or even linked to another parameter's value.
And a condition. What are those?
Conditions are really interesting. They control how the parameter's value gets used. The notes mention self, that means use items from a list in order. Or just use a single value as is.
Okay.
SFLE, that randomizes the order of items in a list. Good for, variety.
All right, less predictable.
And link. This seems important for consistency. It lets you link related sets of data, like maybe link a specific question parameter to its corresponding answer choices parameter. Ensures they stay aligned.
Got it. And the system parameters, those are behind the scenes.
Exactly. They track the state of the agent as it runs. Crucial for multi-turn agents. They let the system remember what happened in turn 1 and use it in turn 2, for instance.
Can you give examples?
Sure. The notes mention things like at TUN, at which might hold the user's input for a specific turn N, or at TRN, at which stores the AI's result or output from turn N, at TSN, for this system prompt sent, at TR for the current turn number. These system parameters are how the agent maintains context across multiple interactions.
And these parameters, both user-defined and system, they tie back into that OMG idea.
Explicitly, yes. The notes position parameters as the mechanism for structuring the knowledge for OMG. They define the features, structure the relationships, assemble the components of that knowledge model that guides the LLM. They're not just simple variables.
So again, it reinforces that OMG advantage. Using parameters means you're giving the LLM structured, relevant knowledge, not just raw text, leading to better, more reliable results.
Exactly.
Okay, so the parameter system sounds like a really core, powerful piece. It's how you define the knowledge, control behavior, and build those complex step-by-step agents.
And those step-by-step agents are built using the platform's turn-based system. This is presented as the core operational logic, another key part of the CAFA protocol.
What's its main job?
Its purpose is really to break down complexity. Take a big task and decompose it into a sequence of simpler, manageable, logically ordered steps of the turns. Each turn is like a distinct phase, often involving interaction. It's how you create those structured task pipelines or workflows.
So you could have turn 1 where the agent gives a greeting.
Right. Then turn 2 might wait for user input.
Turn 3 processes that input using the LLM and maybe some parameters.
Exactly. And turn 4 delivers the output, maybe asks follow-up questions starting the next cycle. It structures the whole interaction.
Are there different kinds of turns?
The notes mention two main types. LLM turns, where the main action is sending a prompt to an LLM for generation, and then symbolic or rule-based turns. These execute predefined functions or processes within the platform, useful for things that need precise, deterministic logic, not creative generation.
How do you tell them apart?
The symbolic ones are typically identified by starting the prompt field with a /T.
Okay. And how does it link turns together? You mentioned those system parameters.
Yeah, that's key for multi-turn logic. Parameters like @trn, at result of turn n, can be used in the prompt or logic of turn n+1, or @2un at user input, from one turn feeds into the next. This is how the agent maintains context and carries out sequential tasks or dialogues. The notes actually call this within agent collective AI the different turns working together.
Interesting. And the user-defined parameters fit into this how?
They provide the specific content or control logic within a turn, guided by their conditions. Self, shuffle, link. So parameters define the what and how for the knowledge, and terms define the when and sequence of the process.
Got it. So for you, the listener, the takeaway is that this turn-based system powered by parameters is what enables the creation of really sophisticated context-aware agents by breaking down complex goals into manageable steps.
The notes also briefly touch on built-in functions and commands, beyond just parameters and turns. These seem to offer extended capabilities.
Like what?
Well, functions are mentioned for rule-based generation where you need precision that an LLM might not give, and also for running simulations like what-if scenarios inside the agent.
That's commands.
Commands seem focused on data handling, input-output, transforming data, storing or retrieving it. They also mention an aim to add commands for generating visualizations like charts or figures.
So extra tools for more specific needs, beyond just text generation. The note suggests more detail as in like a user manual or other modules.
Yeah, seems like these are covered more deeply elsewhere.
All right, let's get to the really exciting part. What can you actually build with this? The notes give some concrete examples, right?
They do, and the examples really show the range possible with this OMG low-code approach. They list things like educational tools, lesson plan generators, quiz generators, maybe even grading assistants.
Yeah, practical.
Also, research and writing aids, drafting research proposals, generating scripts for stats analysis,
Okay.
and even quite specialized content creation, generating medical training scenarios, creating synthetic data for research, drafting survey instruments.
So it's not just generic chatbots. It's geared towards building tools that do specific, useful work in particular fields.
That seems to be the clear message. And they mentioned that code examples and walkthroughs are often available for these types of agents.
Does it talk about managing these agents once they're built?
Briefly, yes. It mentions support for the whole lifecycle, creation, management, deployment, and potential integration with external tools like Google Sheets is noted as a future direction.
What about sharing or reusing agent designs?
Yeah, that's highlighted. Model portability. You can export your agent definition, the parameters prompts, logic, and import it. Good for collaboration, backups, reusing parts.
And once it's deployed, how do people use it?
Deployed agents get a unique web URL. So something like ai.sambalab.com followed by the agent's ID makes them accessible to anyone with the link.
Okay, easy sharing.
So wrapping things up, the CAFA XBA platform really positions itself as this bridge, right? Connecting deep human expertise with AI's generative power. And crucially, doing it through a low-code environment accessible to more people.
Right.
And its real strength, according to these notes, is that ontology model-centered generation approach. Using structured knowledge via parameters to guide the LLMs. That's what supposedly makes the AI reliable, interpretable, and genuinely useful for specific domains. It's presented as moving beyond just basic prompting towards engineered knowledge-grounded AI.
So what does this all boil down to for you, listening in? It means that deep understanding you have of your field, teaching, medicine, research, whatever it is, isn't just background. With a platform structured like this, focusing on knowledge and low code, that expertise becomes the actual foundation for building specialized, high-quality AI tools. Which leads us to a final thought, something for you to maybe mull over after this deep dive. If you could take your own unique expertise, structure it in a way an AI could understand and use, what kind of specialized, intelligent tool would you build? What problem in your field could you tackle, or what new capability could you create with that kind of knowledge-guided agent? Definitely something to think about. Thank you for joining us for this deep dive into the CAFA Platform lecture note.